this video, we're going to discuss how you can use your knowledge of Excel financial functions to handle problems involving compound interest. So what do we mean by compound interest? It means you get interest on your interest. It depends how often you compound it. It could be daily, monthly, or continuously, as an example. So if you have 6% interest compounded monthly, what happens? After 1 month, you have $1 becomes $1 times 1 plus 0.06 divided by 12, and then you just keep multiplying by 1 plus 0.06 divided by 12, which is what we do here. So in a year, you'd have more than $1.06. And if you had 8% compounded, you'd take 8% divided by 12 times $1. That's what you'd have after 1 month. And multiply that times 1 plus 8% divided by 12, etc. So let's solve a lot of problems involving compound interest. So you have $10,000, which is compounded at a 6% annual rate daily. At the end of the year, what would you have? Well, you'd use the FV function, okay? And so the arguments would be like this, okay? Sorry, we should be in here. Okay, so the rate would be the annual rate. We want the rate per day. There are 365 days in a year, we'll assume. So you take the annual rate divided by 365, okay? There is no annual payment per period because you're starting with a lump sum. And again, you want to make this a minus 10,000 because you're putting it in, and the zero doesn't really matter there. But basically what you'd have on $10,000 at the end of a year would be $10,618, okay? Which would be sort of like the deal right here. It's a little different because these are 12 months, 365 days. Okay, so you have $10,000 invested now at 6% rate, compounded monthly, not daily. What do you have in a year? Well, then you take the annual rate divided by 12 because there's 12 months, and then you'll match this right here. Okay, and you have $10,000 now, you put a minus 10,000 there. Now, suppose you get $20,000 in 3 years and the annual rate of return is 15%. What should you pay for that now? There's no compounding there. So you do present value of 15% over 3 years. Okay, there's no annual payment. It's an annuities. It's not an annuities, basically. You just have that $20,000 that you're getting at the end of 3 years. You put a minus 20,000. You're assuming you sort of have to put it in to make this positive. And it's just 20,000 really divided by 1.15 to the third, which is this. How much should we pay now? We get $12,000 3 years from now, okay, and we're getting 9% compounded monthly interest. Okay, well, we would take, it's monthly, so we take the 9% annual divided by 12. There's 36 periods, and basically we're getting 12,000 3 years from now. So again, we put the minus 12,000 there, and so that's equivalent to $9169.79 today. Suppose you put in $800 each year for 6 years compounded annually at 10%. What will you have at the end? Well, again, that'll be an FV function, but here you're putting in a payment. You're putting in a payment each period. So this function is going to look like this. So it's 10%, 6 years, putting in $800 each year at the end. Okay, at the end of each year, we're assuming. Okay. And then basically that zero here means end of each year. There's no value put in at the end of the PV, nothing in your bank account now except those $800 every year. And so you would have not $4,800, which is 800 times 6. You would have $6172.49. Now suppose you put in $200 per month for 5 years, annual rate, compounded 8%, compounded monthly. What do you end up with? Well, then basically take that 8% divided by 12 because it's compounded monthly. You have 60 months. You're putting $200 each month. You put a minus 200 there. We're assuming it's end of month payments. And then there's nothing in the bank now. So you'd end up with $14,695.37. Suppose a property pays you $400 a year for 3 years, an annual return of 10%. Okay, what is that going to be worth today? Well, that's a straight annuity at 10%, 3 years, and you put in minus 400. Because you're putting that bank. So that would be worth today's dollars $994.74. Suppose I get $300 at the end of each month for 6 months, 8% annual rate compounded monthly. What is that worth today? So I do present value. I take 8%, the annual rate divided by 12. Okay, and it's, because it's a monthly rate, 6 months, and I'm putting in $300 at the end of each month. The last zero indicates it's end of month. The next to the last zero indicates there's basically no money put in at the end, so that's worth $1758, less than $1,800 because you're getting money later. Need to pay back $20 in 5 years, 10% annual rate. What should my annual deposit be? Well, what you do is you figure out how much you're borrowing, which would be 20,000 divided by 1.1, 1 plus the annual rate to the fifth, okay? And then a 10% rate, there are 5 payments because it's annual payments. So you 32.75.95, and assuming they're end of the year payments. Suppose they're monthly payments. Well, then you've got to divide that 10% divided by 12, and then you'd have 60 periods. And then what you're borrowing is, if you think about it, it's 20,000 divided by 1 plus 0.01 to the 12th to the 60th, which is a little bit different because of the monthly compounding. You have to bring that, basically the 20,000 you're getting, back to today's present value. Okay, you have a 5639 investment that grows to 15,000 in 7 years. What's the IRR, total rate of return? Well, you take what you end up with divided by what you started with. At 7 years, you take it to the 1/7 power and subtract 1. That's a simple way to get IRR. Okay, or you could use the IRR function, but you don't need it there. $3,170 now, and you get $1,000 a year for 4 years. What's the IRR? These are not really compounding problems, but they're good problems. So you do IRR, and you might have to put a guess in there, but you get 10%. Okay. Now, a lot of times we talk about if we have a 6% annual compounded rate, it's equivalent to what monthly rate? So if we let X, okay, be the annual rate that basically is equivalent, or we'll let X be the rate per month. That's wrong there. So 6% annual rate is equivalent to what monthly rate? So we take 1 plus the annual rate divided by 12 to the 12th power should equal 1.06. Okay, and that rate becomes, there's a function in Excel, nominal. Okay, so basically you take nominal okay, the effective rate was 6%, okay, and you've got 12 periods. Because so if you're compounding, what rate do you need? Basically 5.84% per year. Okay, this should say what annual rate. So that 6% annual compounded rate, basically, if you're getting 6% basically effective, then 5.84 compounded monthly would be equivalent to that. Now, what's the effective annual rate when 6% is compounded monthly? Okay, well, that would be like 1.06, 1 plus 0.06 divided by 12 to the 12th. And there's a function for that called the effect function. Okay, so in other words, if you've got 6%, which is the nominal rate, and you want to basically figure out what that's equivalent to sort of after you compound monthly, it's 1.06 to the 12th. 1 plus 0.06 divided by 12 to the 12th, which is 6.2%. Okay, that's 6.1. That's the one we got right here. Okay, now what if you continuously compound, which means basically every instant you're getting interest on the amount that you have? Well, you could use calculus to show at time t, if the annual rate is r, you'll have e to the rt dollars if you started with $1. So basically, in 1 year, basically, your $1 would become this, which is 1.061837, a little bit bigger than if you compound monthly, but not much. And in 2 years, it would be e to the 2 times 0.06, 1.127. That concludes our discussion of compounding.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.